or in our batch.
इतना था नहीं हमारे टाइम पे it was only 220. Only 220.
The previous 75 batch was.
वो था वो पता किस लिए था वो JK के लिए हुआ था यदुपत कमलापत सिंघानिया. He was the only guy who's not stayed in a hostel. He used to come with a security guy. JK family का guy decent था वो यदुपत सिंघानिया.
ऑडियो और मैं ऑडिबल हूँ. हाँ तो मैं कर देता हूँ. यहाँ तो स्पीकर होगा ना.
Am I audible? Category, you know. वो तो बहुत तेज आदमी.
You may still need to use the mic because the lecture is being video streamed. So you have to be audible to the audience thousands of miles away also.
Okay. No.
So you need to use the mic.
Good. I understand that.
Yeah. So, shall we start? Okay. So, good afternoon, everyone, and welcome to this session. This session is a part of what is called as Amrit, Kaal, Vimarsh, Vikasit Bharat 2047 Development Dialogue. So, how many of us have heard about the term Vikasit Bharat 2047? What is it? What is this Vikasit Bharat term about?
And what's its significance? You know, I think that's what.
What do you understand by this Vikasit Bharat 2047?
We recently had a session where the Prime Minister was under the same themes.
So, basically, if we look into the history of development of nations across the world, we will see that many countries actually, transformed themselves from a not so developed situation or a state into a state where they are reckoned as world powers or world leaders in different domains. And all that happened over a period of a few decades. And if we look at Korea, if we look at Singapore, if we look at China, it's just a matter of a few decades where they came up with policies, came up with ecosystems and support systems so that the country's profile jumped from wherever it was to a completely different level. And that is the stage where we are in as of now. We means Bharat, India today is in that phase where if we do the right things, we have a huge population dividend that we're talking about, a huge population of young people in the country which are keen and willing to contribute to the success of the nation. And in addition to that, we also have almost all the other ingredients in place to help us leapfrog into the next zone, next level. As a part of this Amrit Kaal vision of 2047, the government has identified 5 thrust areas. Those are starting from empowered Indians to sustainable economy. See, let us look at the first one, empowered Indians. What does that mean? That each one of us should feel empowered to do what we want to do and contribute meaningfully. Then the second one is sustainable economy. हम जितनी भी we look at any world power, हम जिस भी world power की बात करें, जिनको हम we may look up to कि हमें ऐसा बनना है. Isn't economy a key differentiator that their economy is at a stable pace, their per capita income is high, and all those things? So a sustainable economy is a very key indicator of a developed nation or where we want to reach as a country. Third one is innovation, science and technology. We cannot reach where we want to reach without innovation and without taking help of science and technology. Am I right? Then good governance and sustainable, good governance and security. That is the fourth one. And the fifth axis is India in the world. So we have to establish India as a world leader. Again, जैसे भी हम इन countries की बात करते हैं, all of them we recognize as world leaders, is it not? So if we have to be there, then unless we engage all of you in that discussion, in that dialogue on how to take India there, whatever we think of is futile, is it not? So today's talk is one of such discourses or dialogues in that direction. And it's titled as Opportunities in the Internet of Things, Perspectives from Today into the Future. And I'm privileged to invite Saibal and Sankalp. Saibal has more than 4 decades, touching 5 decades of experience
It's
in
4.
the electronics industry.
Touching 4.
And a lot of that experience is in IoT and connected and associated technologies. Sankalp again has a vast experience in the industry, and while Saibal is the founder of Connected Sense and Power, Sankalp is a co-founder of Edgelight Technologies. They today work together. Saibal advises Edgelight Technologies, and while Saibal will first introduce what IoT is to all of us, some of us may know something about it, but listening to it from an expert like Saibal is a completely different thing altogether. And then together they will also delve deeper into what are the opportunities that exist. As we go forward, how do we make sense of whatever these IoT devices sense and create applications based on whatever we know from artificial intelligence, from how to take this forward and take it into products, take it into services, and transform India of 2047. So let us welcome Saibal with a huge round of applause to start the talk. And Saibal, we thank you and look forward to listening to you. Please. He will need this also, no?
I need this? Okay. ये on है ना?
हाँ, मैंने कर दिया.
Anyway, a very warm good afternoon to all of you. And it's good that you could take some time off. And first and foremost, I would like to thank Professor Anuj for having us over here. And he mentioned a few of the pillars which is needed for this 2047. See, in nutshell, if we have to be a strong country in the Committee of Nations, he had outlined some of the steps. One key thing is knowledge, science, technology. And with that, we have to see we are able to spread the benefits to a common person. And only when the per capita GDP starts growing up, per capita, mind you, I didn't say the GDP, then only we'll be a successful nation and be considered as a developed country. So the idea is to hit the developed adjective in 2047. So that's the moot point. So with this we start. So I'm having Sankalp, a brief about myself. As you would have seen, I was born in Bombay, but I grew up mainly in Delhi and did my engineering from IIT Kanpur. And then I did my ME from Indian Institute of Science, Bangalore. Sankalp, he did his MTech from IIT Kharagpur. And during my time, in Kanpur, it only had one department called as EE. And EE used to embrace everything, whether it was computer science of those days, communication, electronics, electrical, everything was under one umbrella. Okay, because now I think things have changed. But that used to be the scenario. And during my time, it used to be a 5-year course, of which 2.5 years were common course for all the departments. So that used to be the kind of scenario. Now, obviously, a lot of things have changed. Okay. Now, this is the kind of an agenda that we are following, that we'll be following in this course of our talk. Introduction. We have coined certain terms, ESSN, we'll go through that. Past, when, phases, evolution, present, ecosystem, and the potential. Future, we are talking about roadmaps and the areas where we can use them. And then we have covered few applications, and that obviously embraces the scope for innovation, right? And, sorry. And right in the end, we are talking about trends and challenges. What is IoT? See, this word, internet. What do you think internet means? If I can ask anybody. What do you understand by internet? What is, yes, please, yes.
It's just an interconnecting network of a lot of computers.
Absolutely, yeah. So first, there is a network, and the interconnection of networks is internet. Good answer. So, network of physical objects or things embedded with electronic software, sensors, and network connectivity. And we have coined this term ESSN. Obviously enables these objects to collect and exchange data, creates opportunities for more direct integration between the physical world and computer-based systems. Physical world is the sensors and the actuation, which is right at the endpoints. And what does it do? It results in improved efficiency, accuracy, and obviously economic benefit. We'll find this out more as we proceed. Now, getting to the word things. Now, if you see here, this is the gamut of applications. So it covers a very wide range, starting with smart city. We are talking about sustainable growth, smart city, that's very important. Then smart farming, again we'll cover this. And of course at homes you have got smart TV, smart homes, smart buildings, smart appliances. Now, I think this is a fairly sundry kind of a thing, which I think all of you must have heard of. But there is a plethora of applications which can be applied. And so this is where innovation comes in, both in terms of applicability and how you design those solutions, okay? Which is obviously a combination of hardware and software. And here we have tried to list down what are the various areas: motion sensor, light sensors, gyro, accelerometer, flow and pressure monitor. Of course, this is more for fluids and water. This is the health, heart rate, BP monitor, automobile. Now you must be hearing of smart cars where you're having autonomous driverless cars, So all that comes under this fold. Environment monitoring, again for sustainable growth and ecosystem. Space science and aeronautics. So this is a very wide scope of application. And obviously limited by imagination and sensor development for specific application. Now, the sensor development happens to be a very, very key thing. So again, a lot of innovation And this sensor development is a multidisciplinary kind of a thing. You can think of, suppose you want to make, say, a pressure. I'm just giving an example. One has to know what that pressure is. What are the different factors which impact pressure of a pipeline? What are the materials that should be used? If it's a corrosive atmosphere, what has to be selected as a material? So all these things have to be kept in mind. And you would need people with a multidisciplinary background to sit together, discuss, and then design those kind of sensors. So there's a fair amount of challenge in that. How it works? I think result of several complementary technical developments and capabilities, which taken together help in bridging the gap between virtual and physical world. So capabilities we have just listed here: sensing and actuation, identification, localization, addressability. Now, all these things, I think you people will understand as we move forward. Embedded processing, I think most of you are aware of this, typically happens in the MCU, microcontroller. Communication, how do you communicate across different interfaces? And the user interfaces, which should provide a user-friendly means of navigating through and controlling the device, and getting the kind of information that you would like to capture. And obviously with AI now emerging, it would give you the trend, it would give you a lot of futuristic view, what can be done to improve certain things. And this is the brief about, so basically you have a data, one which is creating data, this could be the sensor, and you could be doing some processing. And finally, how you're outputting and controlling the endpoint, which say is a part of the actuation process. And in between you have this storage, where you can start storing huge amount of data. Much of it would be used in future for AI-based estimations. Any questions till now? Yes, please.
What do you mean by localization and addressability?
See, localization means where, okay, we'll consider this when you, localization means to find out from where what is coming. So for that purpose, like if you have done data structures in your C programming, you have to start defining those things, you know. It's like you can think of each object is a part of a large data structure where you start defining where this is located and you give some attributes to that. So that is the localization aspect. Okay. Localization and addressability, they go almost hand in hand. Now, if you delve into the brief history, this term IoT emerged around the turn of the century, last century, or this century. And this was given by one Kevin Ashton at Procter & Gamble, USA, who was using RFID chips on products to track them through the supply chain. So at that instant of time, RFID was seen as a prerequisite for the IoT. So you had an RFID, and with that, one started tagging. Now this RFID data became very popular, you know, all these metro cards and all these, metro I mean in this, our Delhi metro. That is one of the areas where RFID was being used. And then of course you had near field communication as a backup technology. Okay. Now here we are talking of different subsystems which comprise a general IoT. The first one on the top left is where it is getting applied, means where it is getting used in a physical world, manufacturing, then sensors, actuators, smart appliances. And what is that environment? Which is on your top right, cellular networks. And supporting them are various communication standards like Sigfox, LoRa. LoRa is long range, wide area networks. And in the shorter sphere, you have things like BLE. BLE stands for low energy Bluetooth, and Zigbee. I don't know how many of you have heard of Zigbee. Zigbee is another standard. It's a meshed technology. We can talk about it in the end. And as we had talked before, in next concluding slide, you will see this in the next slide. You would have a hosting server, and that is what allows you to build up on a database. And getting back to the physical world, which is helping in the implementation, is the MCU firmware. There can't be anything without a firmware, okay? So MCU is microcontroller unit. And supporting that is the platform APIs, along with the user interface, which can reside in a mobile phone or it can be in a terminal. So all these elements go to define different subsystems, which comprise an IoT subsystem. Is it clear now? Now, this is one subsystem which we are trying to define. We are calling it as an ecosystem. Now, here if you see, you have got sensors. So this is smart wearables, like nowadays you have all this fitness things, monitoring of your heart rate. And then there are other smart things like smart car, smart home, smart appliance. And these are communicating data to intermediary communication and processing devices. And then from here, if you remember, we were talking about storing things in a server, which was there in the previous slide, where we had talked about hosting servers and database. So that's over here. And this is the database. All this is being done on real time. But obviously, when you're traversing through this path and taking some decisions, there will be some latency. And if you want to knock that latency off, you could have a direct communication path. So this is a direct one. So you can take actions based on this, through this path. Otherwise, it goes through a little circuitous path. So there could be instances where you don't mind storing data with latency, but any actuation which has to be done, that has to be instantaneous in real time. Like if something is about to overflow, you'd like to quickly turn off, say, the input water source. So that immediate action of, say, turning off is being done here. Whereas the user can get a feedback maybe after 1 second. It doesn't matter. You had, yes, please.
Computation thing, does it happen in the cloud or in the...
It can happen both. But nowadays, more and more of that is happening in the device. So they are calling it as edge computing. That's the new trend that is emerging, okay? Because doing things on the server does make sense. But then what happens is servers have got huge compute capabilities. So you wouldn't like to waste that on doing something much simpler, which can be done more elegantly in a small, say, MCU, Because now MCUs are also becoming more powerful. Does it make sense to everybody now? Now, here if you see, there's a word which we have used, context discovery, Now, what is this context discovery? Any information that's relevant to a given entity, such as a person, a device. So this is more about that localization aspect on an application. Contextual information falls into a wide range of categories: time, location, device, identity, user, the role that thing is playing, privilege level, the kind of activity it has to undertake, tasks, processes, and nearby devices and users. So each of this here, wherever you see this yellow bulb, is like a context discovery. So now, if we go back into a little bit of a small other example, like if you have a mobile phone which has a backlit light, when you take it very close to your ear, you're not able to, you don't need the light that time. So automatically, a sensor, which is a proximity sensor, can guess that you're doing this, and it will shut off the illumination. And thereby, what conserve power? Extend the battery life, without having to recharge. So this is just to give one of the very simpler instances of context discovery. Okay, now this is another evolution. As you would see, it started off with network, host to host, then internet, mobiles plus people and PCs. And today, finally, we are in this Internet of Things, and which is being used to control. I think you people in general would be having the same idea of this. And obviously, in this data communication that is happening, which is absolutely key, there are various protocols. Currently, what is being used or deployed is MQTT, which is message queuing telemetry transport. Now, there is some charting about the time frames before 2010, 2015. And as we have seen, it was the turn of the century, 1999, when this IoT business was first, conceived. Then 2015, 2020, and today we are, of course, over here. Now, if you see how the progression has happened, initially there were sensor networks, and all these things played a role: relational database, event-based platforms, sensor middleware, sensor networks, proximity localization algorithms. And then, as things expanded, you had to augment the capabilities of software and the algorithms, which is as per the definition over here. 2015 to 2020, network content awareness. So things are becoming to get smarter. Goal-oriented software, distributed intelligence in problem solving, things-to-things collaboration environments. And today, network cognition. Cognition means able to recognize and, take a learned, self-learning and self-repairing networks. User-oriented software, invisible IoT, easy to deploy software, things-to-human collaboration, and IoT for all. Now, this IoT for all is what makes it sustainable and an all-permeating experience for everybody. Now, this is another view, starting from 2003, that is turn of the century. See, the world population is 6.3 billion. Connected device was 500 billion. It's about 1/12. As we are moving, you would see population has grown, but not that exponentially. But listen, from 500 million, it's gone to 12.5 billion. Okay, it's about 25 times. Then from 12.5 to 25, doubled. 25 to 50, it's again doubling. Now, right now, if you see here, the world population only is this, 7.6. but the number of devices are sevenfold. So there has been an exponential increase in the number of connected devices. So people are finding utility, uses, more applications, more scenarios, things getting cheaper in the market. So all that is pushing things in that direction. So you would have more and more connected devices. So now what happens when you have 50 billion machines connected? So real-time network planning has to be done. Shipment visibility, it's like tracking a movement of a good, say, when you're getting it from a courier company. You can track this here. So you can tag the device and start tracing what is the path that is being followed. Then if you go to any hospital, patient monitoring, this is also something which can be done. So if there is somewhat of a critical condition that a patient hits, all the relevant people can be informed simultaneously. So they can all reach the spot and give express service. And then you have got something called an industrial internet. Now this is called an Industry 4.0, that's a standard, so basically in that, suppose a company has various plants running 24 hours across the world. But the person could be sitting in one place, he's able to monitor, he or she is able to monitor what's happening in different plants, give commands, control them, know in real time what is the kind of output that is emerging. So all this is covered under a standard called Industry 4.0. So again, this is factory optimization. Now if you see here, we have written something called as smart grid. Smart grid is obviously to do with the electricity. And this is becoming as and when the solar cells, wind energy, all these other auxiliary, non-fuel based powering up happens, smart grid will start playing more and more important role. India is playing a very key role in this area right now. Okay, then logistics optimization is the same thing as shipment. So they've used very superlative terms like brilliant rail yard, brilliant hospital, brilliant power, brilliant factory. So the idea is to have as much information as is necessary for efficient utilization. Any questions on this? Now, future of IoT. Now, this is basically inputs from various companies, Bain, McKinsey, IHS Market. So this has been detailed over here. Like if you see, the interesting thing is they are talking about 12% annual growth. And by 2020, it's expected to hit about 125 million. Currently, we are in the range of about 55 billion or so. So basically, almost more than double. Then there's another survey company, Gartner. It is expecting 20.8 billion will be in use by 2023. So devices are there, lesser, but connected things are so much, okay? And the level of income that is achievable would be something like $3.7 trillion. Trillion is a big, big figure, right? And 75% of the new cars will come with built-in IoT connectivity. Now, I don't know how far of this is going to be achieved, but this is what was being projected a few years back. Anyway, the same thing. Now, the key point is great improvements in the security of IoT devices driven by manufacturers' own initiatives, as well as users' demand for better secure devices. Now, this is going to be the key thing. Anuj had also mentioned about security. Now, this is going to be a very important. So you don't want somebody hacking into your system and trying to steal your data and Because the data that you gather itself is going to be very valuable. You can use that data to augment your business opportunities. So you don't want anybody to pilfer that. Now, global manufacturers will use analytics data recorded from connected devices. Obviously, this is going to be in the, we had seen, database, analyze processor, identify, optimize, and possibilities. And of course, this is by IDC and SAP. This is what they have predicted. And I think more of this will start happening in course of time. Now, we were talking about examples. This is more from the industrial usage of IoT. This is massive. Typically, for your consumption, maximum amount of power that is consumed in the industry, close to about, I think, 45%, is consumed by motors. If you take a worldwide view, 45% of total energy used by industry is consumed by one single thing, that is the motors. And here you have various, So we've covered things like aviation, power, healthcare as an industry, rails, oil and gas. And the type of savings, you see this percentage is fairly minuscule. They're talking about 1% saving, 1% saving. But the kind of benefits it will reap are massive. 30 billion, 66 billion, 63 billion, 27 billion, 90 billion. Why railway? Why it is a little less? Because in many countries the rails they are running on diesel. So as you would see, a very small percentage of reduction in efficiencies and in capital spending results in a huge saving for all. So obviously, if these numbers are augmented, this would again start shooting up exponentially. Okay. Now, in fact, you had answered that question. Internet of Things, what is it? Individual networks connected together with security, analytics, and management. And what we have seen in the past slides, what does it do? It results in improved performance. Oh, God. Improved performance, reduced costs. It allows you to think and create new innovative services. And you use that service to create jobs and have new systems of revenue. So this is again left to one's imaginations, innovation, and the better you can think and in advance, more of this would fructify. Okay, and here we have covered various broad categories: transport, education, home, business, earth. Earth is obviously sustainable stuff, along with energy, and others. Now, these are various applications. We have some idea: enterprise solutions, smart homes, smart cities, agriculture, manufacturing, healthcare, media, environment, infrastructure, energy, transportation, better quality of life for elderly people. Now, this is going to be, again, a very big emerging aspect, Many of these developed countries, so-called developed countries, are today facing problems. They don't have a very young workforce, nor do they have people who will look after the elderly people. So there's a very big demand to have such people. And it so happens that India is one of the places that is being looked up because of our demographics and all that to provide this kind of a service. And if you again see, the broad category is home, smart transport, health, buildings, and smart cities. So you name it and you have it in IoT. So all these applications are going to get augmented, amplified. It is happening in some places, but more of that would start happening here. Okay, this is one slide. Even today, sensors are being used to monitor amount of milk, ensuring farmers to monitor cows' health, track their movements, ensuring a healthy and a more plentiful supply of milk for people to consume. On an average, each cow generates, you see, in cows, they have it on their ears, implanted these sensors, about 200 megabytes of information per year. This is the kind of data which can be collected, or this is typically the data that is being collected per cow. So obviously the magnitude of this is massive. And based on this, you can start predicting, which part of the year and when it is lactating, Again, further application in smart city, something which we call as smart parking, efficient waste management. I think India needs to focus a lot on this arena, and we are still very far off from that. It's not only, many cities in India need this service very, very expressly, in an express way. Now, as we had seen, by 2023, they expect a lot of connected cars. So this is going to be the category of things, that is going to happen. The connected car market, the consumer perceptions, autonomous cars, we are talking about that. And here is a list of players, BMW and, Mercedes, Audi, who are in this domain. Connected car is equipped with internal connections and software that allows people to stream music, look up movies, be alerted of traffic and weather conditions, and even power driving assistance services such as self-parking. So you could do all these kind of things without much of an ado. Now, you've heard of this company Gartner, right? So Gartner is a company which focuses a lot on market surveys and all that. Artificial intelligence, this is going to be the next realm of things. Data is the fuel that powers IoT, and the organizer able to derive meaning from all of it will define the long-term success. And then there is social, legal, and ethical IoT. Should not be used just like that. And then you have infonomics and data brokering, people who would use these information for further business generation. Theory of infonomics takes monetization of data further as a strategic business asset to be recorded in companies' accounts. So whatever data that you collect in your database, that is going to be a very, very critical thing. So you have to put in places things which are very secure and cannot be sort of purloined. Intelligent edge to intelligent mesh. Shift from centralized and cloud to edge architectures, as is in IoT. And using IoT for e-governance. Okay. So all this, even Anuj had spelled out right in the beginning. And these are, again, some of the things which we've already talked about: sensor innovation, trusted hardware and operating system, novel IT user experience. So again, this is where user experience is driven by 4 factors: new sensors, algorithms, experience architectures, and context, and socially aware experiences. Now, this is where things will come in. New chips are coming in, silicon chip innovation, special purpose chips which will reduce power consumption to run IoT devices. Coupled with this, you would have AI-powered chips, which is going to improve it even further. New wireless networking technologies. Like we have developed solutions based around 4G, but obviously 5G, 6G, these are the new set of things which are coming. So all that would have to be catered into the networking part of the IoT solutions. So this here we have just briefly talked about amalgamation of or confluence of AI and IoT. So this is the broad subject field starting from parallel processing, statistics, machine learning, deep learning, neural networks, reinforcement learning, decision trees, and random forest. This is again, many of these things you would be possibly studying right now or in your courses to come. Then these are again, actually this OT stands for operational technology. This first principles, modeling, decoding of experience, plant safety, so operating procedures. And then this is the other thing. This is the IT software and scale, cloud, simulation, modeling, high performance computing, distributed computing, enterprise model welfare, then data analytics, reliability. Now, we have tried to list down various things, what is important, and it comes under which sphere. So the future is moving in this direction. And how does it happen? How to explore? Market awareness, areas of expertise, promise. So these are the value addition. Hash me too was innovative. No, hash me too is a copycat. Innovation was adaptability and return on investment. These are the key attributes which have to be looked up to. And this is how things would progress, benefits to humanity. And as a result, what is most important, you will start off once when you are wise, so that's wisdom, understanding, knowledge, information, and data. So this is how one has to acquire knowledge to hit the pinnacle. Challenges. Obviously, scalability is a very important thing. Technological standardization, interoperability, discovery, software complexity, data volumes and interpretation, power supply. Because power supply, again, from a sustainable standpoint, is again a very important thing. Interaction and short-range communication, wireless communication, and fault tolerance. Have people been taught about fault tolerance systems? Okay. See, basically in fault tolerance systems, you have one particular module which is working, and you have a mirror image of that which is running in real time in exactly the same phase as the one which is actually connected. Now, in case the one which is working develops a failure, seamlessly it should get transferred to the other one without any need for rebooting or anything of that. So it's called as hot standby. That's also another term that is used. Now, obviously, any new thing that emerges, there's always accompanying criticisms and, concerns. Oh. Oh, God. So which are the areas? Privacy, security, autonomy and control, social control, political manipulation, design, environmental impact. Now, a lot of people, when they see certain things happening, would raise these as the main issues. Okay? Now, we have to be judicious enough to know, that's why that word wisdom in that triangle thing was very important. So basically, scholars and social observers and pessimists have doubts about promises of ubiquitous computing revolution in the areas as has been listed here. So that should not be a deterrent. But in a democratic system, one has to argue that in a proper frame of mind with supported by proper data. So this is only tip of an iceberg that is over here. So here I've given some acknowledgements. Artificial intelligence, industrial IoT, convergence of this thing, GE cloud computing, emerging global trends in IoT, okay? So I think that, so this covered more or less the brief introduction with more stress on different applications that can emerge in future. Any questions? Okay. Thank you. What do they say? Oh, sorry. एक मिनट. मेरा गला थोड़ा खराब है. I don't know how it was. हाँ.
सैनल भी मिलता है, लुई विटॉन मिलता है, सारे कुछ मिलता है, सारे मी टू टाइप के प्रोडक्ट हैं, बट बिकते हैं ना, सारे मॉल में आपको सारे दिखते हैं ना, दे हैव द बिजनेस, राइट? हाउ दे आर डूइंग द बिजनेस? सेम प्रोडक्ट है, बट बिजनेस तो बना रहे हैं वो, कैसे बना रहे हैं? देर मस्ट बी सम डिफरेंशिएशन बिटवीन दिस, सेम प्रोडक्ट है फिर भी बिक रहा है, कैसे? सो ईदर यू डू अ मी टू प्रोडक्ट और यू डू अ इनोवेटिव, और यू से मैंने इनोवेटिव किया है बट उसको मार्केट में अडोप्टेबिलिटी है या नहीं है. दैट्स वाई आई आस्क फॉर द आइडियाज कि आइडिया आपका क्या है. इफ योर आइडिया इज बेसिकली अडॉप्टेड बाय द मार्केट, देन यू विल बी हैविंग अ सक्सेस, राइट? मार्केट में अडॉप्ट नहीं किया, आपने बना दिया R&D पर्पस के लिए या फॉर कॉलेज में, सॉरी अबाउट दिस, बट कॉलेज में मार्क्स पाने के लिए आपने कुछ रिसर्च प्रोजेक्ट बना दिया और आपने अच्छा खासा पब्लिश कर दिया, बट मार्केट में अडॉप्टेबिलिटी है या नहीं है. सो यू नीड टू थिंक ओवर दिस कि अडॉप्टेबिलिटी क्या है आप मार्केट की. सो दैट्स वेयर इनोवेशन वर्सेस अडॉप्टेबिलिटी कम. एंड व्हेन वी स्टार्टेड दिस, मतलब हम लोग भी आप लोगों के जैसे थे, व्हेन वी स्टार्टेड कि अपनी कंपनी खोलते हैं, कुछ बनाते हैं, कुछ करते हैं, we did, like I said, ki IoT is a big space and galaxy, within the galaxy you come to the Milky Way to your planet. So within this IoT space, we thought of what are we going to do, what is our expertise, what kind of problem we can solve, and then we think of industrial IoTs, like Saibal just already touched on I 4.0, industrial 4.0. Industrial 4.0 is basically doing the thing जो मैनुअल चल रहा था उसको ऑटोमेट करना है. नाउ देयर इज अनदर थिंग कमिंग अप, I 5.0. I 5.0 क्यों आया? 4.0 तो बना दिया था, 5.0 क्यों आया? अपग्रेड थोड़ी करना सॉफ्टवेयर को, क्या है इसमें? व्हाट्स देयर इन 5.0? अभी क्या हुआ था, भेड़ चाल चलती है. 4.0 आया, दैट मीन्स की ऑटोमेशन करना है. टॉप टियर 1 कंपनीज गोइंग फॉर दैट कि ऑटोमेशन करना, ऑटोमेशन करना, ऑटोमेशन करना. इसका इम्पैक्ट क्या हुआ? द मैन पावर विच दे आर यूजिंग इज नाउ हैविंग अ थ्रेट कि यार सारा कुछ तो मशीन कर देगी, मेरी क्या जरूरत पड़ेगी. एंड द ओनर सेज मशीन एक बार लगा दूंगा, एक टाइम का इन्वेस्टमेंट है मेरा, आई हैव जस्ट वन टाइम इन्वेस्टमेंट ऑन द मशीन, मेंटेनेंस वगैरह थोड़ा सा कम होगा, सैलरी तो नहीं देनी पड़ेगी, ह्यूमन एरर मैंने हटा दी, बट सैलरी नहीं देनी पड़ेगी, आई विल गेट सम रिटर्न ऑन माई इन्वेस्टमेंट. सो वी लुक इन टू द ROI. दैट्स द टर्म दे यूज इन द बिजनेस एरा. आप CA वगैरह को सुनोगे, मार्केट वगैरह को सुनोगे. सो आपने कुछ पैसा लगाया ऑन एनी प्रोडक्ट और एनीथिंग एंड यू लुक इनटू दिस, मैंने X अमाउंट डाला, X प्लस डेल्टा कब आएगा? एटलीस्ट मेरा X तो आए पहले, एक साल में मेरा X आ रहा है, नहीं आ रहा, चलो 2 साल लगाता हूँ, X प्लस डेल्टा आ रहा है या नहीं आ रहा. से फॉर एग्जाम्पल सोलर प्लांट लगाया आपने, इंडस्ट्री में सोलर प्लांट लगाया आपने, एंड सोलर इज बेसिकली इनिशियली देयर इज अ लॉट ऑफ इंस्टॉलेशन के लिए पैसा ज़्यादा लगता है, टू पुट इट इन दैट वे. एंड आपने इंस्टॉल कर लिया, से आपने 20 लाख लगा दिया, फैक्ट्री में ऑटोमेशन कर दिया आपने सोलर प्लांट से टू जनरेट द पावर, राइट? नाउ द मोमेंट यू पुट द प्लांट इन प्लेस, द नेक्स्ट थिंग इज कि मैंने इतना पैसा लगाया, मेरा पैसा कैसे होगा? जब सोलर इतना पावर मेरे को कितने सालों में जनरेट करके देगा, सो दैट आई विल सेव द मनी. यू कैलकुलेट समथिंग लाइक कि यार चलो मेरा पर यूनिट है 10 रुपीज़ पर यूनिट आ रहा था ऑन द ग्रिड लाइन, जो नॉर्मल मीटरिंग से हो रहा था, इंडस्ट्री में 16 रुपीज़ हो जाता है. एंड यहाँ पे सोलर से मैं इतना जनरेट करके कितने सालों में ये पैसा मैं उठा सकता हूँ. दैट्स द, उनका माइंडसेट ये होता है, राइट? उस माइंडसेट से वो इन्वेस्ट करते हैं हर चीज़ में. दैट्स वेयर दे मेक मनी. अब यू माइट हैव हर्ड कि अच्छा न्यूज़ आता है IITs में द इनिशियल सैलरीज आर सम 1.2 करोड़, 2 करोड़, 3 करोड़, राइट? So you think over it, the company is giving a fresher this much of money, right? So आप इमेजिन करो वो कंपनी कितना प्रॉफिट बनाती होगी, तभी तो आपको दे रही ना, अपनी जेब से तो नहीं दे रहा, राइट? सो वो कंपनी कितना पैसा बना रही है ऑन बेस्ड ऑन दैट प्रोडक्ट, राइट? यू गाइज आर हैप्पी गेटिंग द गुड सैलरीज, अच्छा खासा सैलरी मिल रहा है, लेट्स सी. बट लुक एट दीज गाइज जिन्होंने की प्रोडक्ट बनाया एज अ इनोवेशन, उसके बाद देन दे आर मेकिंग मनी on this, right? This is the global trend. इंडिया में जाएंगे और इमर्जिंग मार्केट्स में जाएंगे, they are very cost sensitive guys. Cost sensitive in the sense they will say we go to the guys and say कि अभी हमारे पास ये प्रोडक्ट है, दे विल गिव देयर स्पेक्स, कि मुझे फरारी के स्पेक्स देते हैं वो, दे विल गिव ऑल द स्पेक्स ऑफ फरारी काइंड ऑफ थिंग्स एंड दे विल गिव द मनी लाइक अ टाटा नैनो। टाटा नैनो के प्राइस में वो फरारी लेना चाहता है। सो द प्रोडक्ट विच यू विल बी थिंकिंग ऑफ इट हैज़ टू बी अ कॉस्ट इफेक्टिव अनटिल अनलेस, मतलब आपने बहुत बड़ा प्रोडक्ट बना दिया, लॉट ऑफ इन्वेस्टमेंट इज देयर मार्केट में, वो कोई लेगा नहीं। सो यू नीड टू थिंक फ्रॉम टू एस्पेक्ट्स, आपका वैल्यू ऐड कर रहा है कि नहीं उसकी चेन में, एंड आपका कॉस्ट कितना बन रहा है उसका। अगर कॉस्ट इफेक्टिव सॉल्यूशन नहीं है, मार्केट में सर्वाइव नहीं करेगा। वी टॉक्ड अबाउट दिस राइट इन द फर्स्ट सर। Yeah, I will go quickly. In fact, I have a lot of slides, but I will go quickly. Okay. So we just started on this, and thinking over this, हम लोगों ने industrial IoT पे we build the product, which is a 4G gateway, come data logger, come modem, which caters to different industries. Like हमने पहले क्या किया था कि we build the IoT, अपना हार्डवेयर बनाया, because we know our expertise, we are good in hardware design, we are good in firmware development, device drivers वगैरह जो हमने सालों से अपना experience था, we utilize that and we developed a product. And doing that product, उसके बाद हमें realization हुआ कि this product can be fit in not only to one industry, it can fit into the solar, water distribution, energy meters, and so on so forth. Plastic industries में भी हमने लगाया हुआ है, conventional energy है, solar energy है. So same product can be changed to adopt the applications. आप उसको industrial mode में कर लीजिए, आप उसे M2M mode में कर लीजिए. M2M, you guys know about the M2M? No? Okay. So talking about the network, right? Network की बात की थी जब सर ने स्लाइड दिखाई थी. Host to devices, वहाँ तक पहुँचा था, right? Now M2M क्या करता है? M2M is basically machine to machine. One machine can talk to each other, right? Without having any interference from the cloud or anything. Okay? So आपने यहाँ पे रखा, like we communicate one to one, right? So machine can communicate one to one based on the technologies which you are using. So LoRa is one of the technology where you can have peer-to-peer communication between the wireless communications I'm talking about. And we build this on the 4G network. On the 4G things, we can do a master-slave peer-to-peer communication between two mobiles. Say two mobiles are talking to each other. और अभी मोबाइल आपके हाथ में, but you place it on the device से सेंस करो आप अपना data and they can talk to each other in synchronization manner. So that's the M2M mode. Then you go to the autonomous mode. Autonomous mode is basically machine is itself is intelligent. You got the question. One question is, edge computing कर रहे हैं या cloud computing कर रहे हैं? That depends upon the application. How heavy is your application? Say for example, you want to do a video streaming, do a post processing of the video data. That requires a huge amount of processing power. Okay, so if your device is capable, edge device is capable, you do the computing power over here, compute over here, send the relevant data over the network. What you are doing here is you are saving the network bandwidth, right? Which is basically a chargeable. अभी तो सस्ता है, but over the time अगर आप HD stream भेज रहे हो अपने device से cloud पे processing करोगे, then you send back the data. आपने एक तो latency बढ़ा दी, ऊपर से आपने processing वहाँ पर नहीं किया, right? So you can do edge computing on those cases, right? And then some of the guys don't want even the network, कि मुझे cloud पे नहीं जाना है. So ये हमने अभी यहाँ पे दिल्ली में BSES में लगा हुआ था, जहाँ पे कि यहाँ पे तो खैर ठीक है, पावर का सिचुएशन ठीक है, बट दिल्ली में कुछ एरियाज हैं जहाँ पे अभी भी मतलब चोरी करते हैं लाइट की, राइट? एंड पीक टाइम में लोड इज लाइक एनीथिंग, सो दे हैव टू डू अ लोड शेडिंग. एंड लोड शेडिंग के लिए उन्होंने SMS बेस्ड कंट्रोलर मांगा था हमसे कि ये जस्ट बैठा हुआ CEO बैठा हुआ SMS कर दे, ऑन करना ऑफ करना. There are two reasons. One is they don't allow the linemen to go there to cut the things. दिल्ली में अभी भी कुछ एरिया हैं जहाँ पे अलाउड नहीं है. आप लोग ने यूपी बिहार का सुना होगा, दिल्ली में भी ये है. So the simple solution is you put your device onto the RMU unit बोलते हैं उसे, रिंग मॉनिटरिंग यूनिट, and do the load shedding. Just यहाँ से आपने SMS से command भेज दी, it will switch off the power from that place. Okay, so that's a webless mode. ये तो मेरी सेल्स स्लाइड है जहाँ पे कि हम बताते हैं वायर्स मेक इन इंडिया है और ये सारा कुछ है. एंड देन द कस्टमर्स, सो दीज आर आवर गुड कस्टमर्स व्हिच गिव्स मनी टू अस एंड वी आर हियर. सो पिच इन हम लोग ऐसे मारते हैं कि हमारा प्लग एंड प्ले डिवाइस है एंड सो ऑन सो फोर्थ. दिस इज नथिंग टू डू विद द IoT, दिस इज मोर ऑन द बिजनेस पॉइंट ऑफ व्यू. सो आई विल गो. सर मेन मैंने इन्होंने बता दिया है कि व्हाट वी आर डूइंग. Now I am going for the application. If you guys, anyone of you interested in any application, I can go into the detail. But there is a time shortage, so मैं अभी detail में नहीं जाऊँगा on each slide. I will just show you the application because one of the guy asked कि यहाँ पे applications क्या क्या होगी, because he was fancying about this curtains हैं, remote से चल रहे हैं, smart bulbs हैं, how the smart bulb works and so on so forth. But there are actual field applications. Industry में क्या demand होती है? So one is solar. Where solar is basically आपने सोलर से पावर जनरेट कर दिया, प्लांट में लगा दिया. अनफॉर्चुनेटली यू कैन नॉट एक्सपोर्ट द पावर टू द ग्रिड, कि आपने पावर जनरेट किया एक्सपोर्ट कर दो इन सम एरियाज. सो दे कॉल्ड इट जीरो एक्सपोर्ट डिवाइस. यू कैन नॉट एक्सपोर्ट द पावर जो आपने जनरेट किया है. इसके अगेंस्ट में देयर इज अ नेट मीटरिंग. नेट मीटरिंग इज बेसिकली आपके पास कुछ पावर है, आपने अपना कंज्यूम कर दिया एंड देन यू एक्सपोर्ट द पावर. बेस्ड ऑन योर एक्सपोर्ट्स एंड कंजप्शन there will be net metering. That's a net metering. So these two are mutual. Then there is a DG synchronization. Light चली गई है and आपको DG के साथ synchronize करना है with your solar. How do you do that? And also अभी hybrid inverters आ रहे हैं, which is basically inverter plus battery management system. So BMS with the inverter and grid and DG, all those combined together is the solar plant system. So you can control each of things based on this. And also there are एक interesting question. Somewhere I have written this. Integration of weather monitoring system. So solar है, solar में सबको पता है कि यार sunlight आएगी, power generate करेगा PV volt से, some percent of energy will be converted into electricals, right? And that electrical DC energy will be converted into AC and then send it to this. Solar का समझ में आता है कि sun bright होना चाहिए, pollution नहीं होगा तो आपको अच्छा आएगा. The weather sensors which they are putting up, there is a wind sensor as well. Any idea how wind can impact the solar power on the solar generation? सोलर का तो समझ में आ गया कि जितना रेडिएट होगा, जितना अच्छा लाइट पड़ेगा उतना पर जनरेट करे. बट हाउ द विंड इज अफेक्टिंग द सोलर जनरेशन, राइट? सो जब आप फील्ड में जाते हो, देयर इज एक्चुअल यूज केसेस जहाँ पे कि आपको हैंडल करना होता है ये सारी चीजें. दिस इज अ फूड फॉर थॉट फॉर यू गाइस. यू थिंक ओवर इट. हाउ कैन विंड अफेक्ट्स द सोलर पावर जनरेशन? ओके, आई विल लीव इट टू यू. जो दिखता है वो बिकता है, दैट्स द फंडा, राइट? सो बेसिकली यू नीड टू गिव द विजुअलाइजेशन एज पर द क्लाइंट नीड. You make the dashboard. The dashboard is basically on the, I'm just giving the example on this. So this example says, आपका power generate हो रहा है and what is the plant capacity, what is the power generated by the grid, what is the power generated by the inverters and DG and what time. What is the, there are technical terms like MPPTs and strings. So maximum power tracking करते हैं आप. And strings are basically each of the solar panels has strings coming on और वहाँ पे आप power में current measure करते हो कितना generate करके दे रहे हैं. And there is a data logging. So I will go quickly now to the different application which I think clock is ticking, right? Okay, so I will quickly go on this. This is solar. Then we worked on the Har Ghar Jal Mission Yojana जो government की है. The mandate is basically by 2024 all the rural areas. The furthest point has to be a tap water, good quality tap water. Supply is okay. आप civil engineering कर लो, electrical engineering कर लो, pump लगा दो, and all those supplies has to be there. So the first target is to reach to the end point, and then there comes the monitoring of this. How good quality water is coming over there. So this is the JJM on this. You see the tank, the main supply and the end point. all are the IoT applications. On this IoT application, you just put your devices, get the data from overhead tanks, कितना खाली है, कितना भरा है, कितना pressure से pump जा रहा है, so that यहाँ पर कितना metering आएगी. All those things has to be there, and then it goes to the data, and this cloud is maintained by the 2 levels. One is state level, and one is, in fact, 3 levels. One is Gram Panchayat level, then the state level, and the center. So each thing has been monitored. Different layers, as Saibal was suggesting. आपका water resources हैं, you put the sensors over there, get the data. From this data, these are the sensors which is on this particular application: chlorine sensor, pressure sensors, and pH sensor, and that flow meter to get the flow. And then put your device. Use any of the protocol which is basically there. So you can use FTP, HTTP. To go into the security point, you can use HTTPS, or you go to the TSL, SSL link layer pe, and you put MQTT over there. Then everything has to be on the dashboard. Visualization is the key. If you just creating a device, and आपने बोला device में दे रहा हूँ, and you take the rest of the things from other places, that will be very difficult and challenging. So you need to do end-to-end solutions. As I said, our mission was to go to the idea on paper to complete solution. So that's where you need to give up to this level. कोई भी solution अगर यहाँ इस level पे नहीं आया, तो this is another water applications. Industry में अभी government का norm आया है. Each of the industry has to publish their data, how much groundwater they are extracting for their uses, so that water is quite now very precious resource, so has to be used judiciously. This is in Kashipur, Rudrapur, अपना UK वाला, जहाँ पर के you get the groundwater extraction on that industry, वो कितना use कर रहे हैं in each shift. 24/7 shift चलती है उनकी. So each 8 hours there is a shift change, and you need to monitor what is the flow. So each of the this is basically shift A, shift B, shift C, and then trend. What is the trend? So if you look into this dip, this is maybe a weekend, जहाँ पे उन्होंने छुट्टी मनाई होगी, and then there is a dip on that. Also, all the data has, as I said, this is the government project, so all the data reports has to go to the government side. M2M solution, I already talked about the M2M solutions. Machine to machine, एक control room है जहाँ से you can control your pumps, get the feedback. Normal सा एक scenario होता है कि आप somebody बहुत college level का project, you do a pump on off remotely, right? That can be done, right? You guys can do that. How do you ensure आपने जो command भेजी है that is successfully executed, pump is on or off, right? So you need to go two-way communications. Not only you are just sending the command and sitting, मैंने भेज दिया, I'm done with it. So you need to do a feedback. So feedback mechanism has to be there. The command has to be acknowledged properly. Whether the command has been executed successfully, pump is actually on, or is it running or trip. जैसे trip होगा आपको फिर feedback देना पड़ेगा. So that's where the two-way communication happens. It's not just single. जो कभी भी कोई बोलेगा ना आपको कि यार ये बना कर दो, तो उसे मैंने acknowledgement कैसे लोगे आप? This is where the M2M comes into the picture. W2B water treatment plant, आप लोगों ने देखा होगा कि मतलब अभी इंडस्ट्री कानपुर जैसे कभी हमने बात की थी, कानपुर में there is a lot of pollution in the water. So every अभी सोनभद्र है, बूंदी, and all those places जहाँ पे कि water is really contaminated, and water treatment plant is now mandatory over there. So water treatment plant में again this is an M2M solution जहाँ पे कि all the devices has to be put in some groundwater resources है, water treatment का intake है, वहाँ पर आप monitor कर रहे हो, then you see कि कितना monitor आया हुआ है, what is the yield, मतलब जैसे घर पे RO लगा हुआ है या आपके यहाँ पे RO लगा होगा, so if you have seen the RO में input versus output, उसमें एक ratio होता है, right? ऐसा नहीं कि सारा का सारा पानी clean हो जाता है, तो rest of the water has to be discarded or used for somewhere else, drinking purpose के लिए use नहीं करते, so that has to be monitored. Okay. So this is another applications which we have talked about. Control machine, CNC machine. Again, your edge device. Machines are running 24/7. Say वहाँ पे you are measuring the lubricant level or the pressure level. All of a sudden lubricant level dropped. Okay, what do you want to do? You want to generate an alarm. You generate the alarm and take the action. Not only the generating the alarm, you have to take the action immediately. So edge device computing is necessary over there. Based on the threshold, you decide on the edge. Rest of the things can be a bit delayed, latency उसका थोड़ा सा देख के आप report कर सकते हो after 1 or 2 minutes. But action has to be there. Otherwise, machine will go dead, right? So this is where the edge device comes. Similarly, हम लोग ने प्लास्टिक इंडस्ट्री के लिए काम किया था, which is on the powder से आपका जो भी आपका ये प्लास्टिक प्रोडक्ट दिखते ना, so प्लास्टिक प्रोडक्ट बनने से पहले there are 3 processes, 3 to 4 processes. So this guy was working on the extruder machine, जहाँ पे कि प्लास्टिक पैलेट्स आते हैं, पाउडर आता है पहले, पाउडर को जैसे आटा गूंथते हैं ना, that's a kneader machine. Kneader machine will do this kneading, and that from the kneading it tilts to the extruder machine. Extruder machine में then there is a melting at different zones. So there are 5 to 8 zones based on the temperature, different temperature. The kneading plots flows through here. After this, 2 are basically on the heating side and other 2 are on the cooling side. So that last time पे ये pellets cut करते हैं. So this is the extruder machine. Each of the things has to be monitored properly. Like I said that there is a kneader. Kneader का piston आपको नीचे करना है. But अगर आपका kneader complete नहीं हुआ, extruder चल रहा है, आपने नीचे कर दिया, तो piston will go bad. Okay. So you need to interlock this with the kneader machine. So these are the practical examples which IoT has. I already talked about this SMS controller. BSCS में हमने अभी दिल्ली में चल रहा है, पिछले 3-4 साल से ये लगा हुआ है हमारा, already working, and this is on the SMS based. This is where we are. अभी हम यहाँ पर आए हैं आप लोगों की help लेने के लिए. Let's see on this. What is the future we are looking for? Sir, I'm on time, right? So, if you look into this, we are on the structural monitoring, bridge and tunnels. Tunnels का, sir, I will take 2 minutes off. Tunnels में basically tunnels is having a very good and peculiar cases. Tunnels are not like just एक tunnel खोल दिया और हो गया. Tunnel monitoring is very critical. अभी देखा होगा काफी news आ रही थी tunnels का ना, collapse हो गया था, 41 बंदे फंसे हुए थे. Even the tunnel बनने के बावजूद भी आपका tunnel का we have a project doing with the JNK में एक 1.5 किलोमीटर की tunnel बन रही है, which is having 2 bands. Whenever there is a band, you need to see air flow कितना होना चाहिए, air pressure कितना होना चाहिए, whether it's a exhausting fume जो आपको जो वहाँ पे आपके अभी आप जाओगे यहाँ पर प्रगति मैदान के उधर पर, तो जो अभी टनल बना हुआ वहाँ पे देखना फैंस भी लगे हुए हैं, एंड आप जगह जगह पे बॉक्सेस देखोगे. दैट्स फॉर द मॉनिटरिंग पर्पस. द फैन इज अ 2-way फैन. इट जस्ट नॉट ब्लोज द एयर, बाहर नहीं निकलता, अंदर भी सक करता है. सो दैट हैज़ टू बी कंट्रोल्ड. सो ईच ऑफ द थिंग्स हैज़ टू बी डन. सो वी आर वर्किंग विद दिस. यहाँ पर अनफॉर्चुनेटली GSM डजंट वर्क ऑन दैट. जैसे आप लिफ्ट में बैठे हो या किसी अंदर बैठे हो, तो दैट कम्युनिकेशन डजंट वर्क. So we need to change the communication technology. We will be working on WLAN and BLE. Also digital twin. Digital twin is basically where AI will come into the picture. पूरा फैक्ट्री को ये रिप्लिकेट करता है. कंप्लीट फैक्ट्री का जितना भी मशीन है, जितना भी ऑटोमेशन है. इनफैक्ट इन्होंने अभी यहाँ पर जो डैम है, डैम के आसपास का सारा एरिया कवर किया है डिजिटल ट्विन. इवन द उन्होंने माउंटेन्स एंड ट्रीज उसको भी डिजिटल ट्विनिंग की है. That's quite interesting. They just made the virtual reality into the picture on actual field, so that आपको पता होगा कि क्या वहाँ पे प्रॉब्लम आ सकता है. And each of the places, every 100 meters, वहाँ पे सेंसर एलिमेंट्स लगे हुए हैं, so that they give the actual picture. और वहाँ पे कोई भी चेंज होगा, you will get the anomaly. As I said, मतलब इन सारी ट्रेंड्स जगह पर GSM उतना अच्छा सक्सेसफुल नहीं है. सो वी नीड टू डू अनदर टेक्नोलॉजीज. वी विल बी डूइंग द LoRa ऑन दैट, एंड LoRa इज सक्सेसफुल बिकॉज लॉन्ग रेंज है, एंड ऑल्सो ऑन 100 मीटर यू कैन डू द वायर्ड कनेक्शन. सो आपको कनेक्टिविटी वायर्ड चाहिए, बिकॉज वाई वायर कनेक्टिविटी ओवर देयर, मेरे पास डेटा ह्यूज है उस समय, वी आर वर्किंग ऑन द वीडियोज, राइट? सो देर इज अ ह्यूज डेटा डिमांड, so all has to be taken care, so we are working on this. And also like we have already developed on the 4G, so now 5G is coming. हमने चालू किया था 2G से 2G के बाद 4G आया, 4G के बाद 5G आया, so we are working on the 5G, and 5G पे then we have the idea of doing the AI plus machine learning. So we will first start with the machine learning and then putting the AI. Why we are using the AI with our solutions is to get the trends. And with the trends, say solar का trend है या machine का behavior है, that machine behavior over the time we will get the data and do an algorithm to show them कि next year में आपका इतना generation होगा and the machine का life ऐसे चल रहा है आपका. So that where the AI will come into the picture. That's it. Preventive maintenance I don't want to talk. पहले मैंने किया था, but उसका एक अलग story है. We'll cover it later. But that's it. I think. Any question, guys? This is me thanking you guys. कोई question? No questions? All clear? Strange. Thank you. Thank you for your time. अच्छा हाँ सर. Thank you sir.
So, thank you, Saibal and Sankal. So, this indeed was an enlightening talk. You took us through the technology of IoT, and then you also took us to the applications of IoT. And what is interesting is that you closed with an interesting roadmap. Now, to our students, where do you think these technologies are being worked upon? Do you know that at IIIT you are working on almost each and every one of these buckets? So what is happening on digital twins at IIIT-Delhi? Who is working? Do you know? So Professor Sanjit and his team are working on an Industry 4.0 perspective where they are working on digital twins. We have an entire team of professors in the communication group working on technologies like 5G, LoRa, BLE and Zigbee and everything. AIML, we have an entire center of artificial intelligence. ML is in every department, whether you look at biosciences department, whether you look at electronics, whether you look at obviously computers. But every one of us is in some sense or another working on ML or AI. So if you are interested, and that is where this session, that there are tremendous opportunities in the domain of IoT. You looked at a few applications. Agar hum, if you just look at the list of 5 things, 5 pillars of Viksit Bharat 2025, you will notice that we talked about governance, we talked about water management, we talked about sustainable economy, we talk about profits. When you put that IoT devices on a solar plant, what were you talking about? Somehow making the efficiency of those plants, enhancing the efficiency of those plants by just a little bit. And when you do that, as we saw in the estimates from GE, we could save billions of dollars over a span of 10 to 15 years. A little technological intervention and such huge returns can be reaped. And that is where business models can be built. This event is being co-organized. This event is being organized under the aegis of AICTE, but co-organized at IIIT-Delhi with the Institute Innovation Council, the eCell, and also Center for Intelligent Product Development. And you will notice that all these 3 organizations, all these 3 entities in the institute work towards somehow enabling you to turn your ideas into reality. And it all then depends on your willingness, on your imagination, and how much of persistent effort you are willing to put in. What I can assure you is that if you are willing, then there are no limits to where you can reach. So, if there are any further questions to Sankalp or to Saibal, you can meet them on a one-to-one basis. They are around. We can talk just now also. You can also reach out to them. They have already given their contacts, or the contact information can also be got from me later. And you just do not feel limited in any way. If you think of opportunities are always there. But to milk those opportunities, there will always be some obstacles. That is where persistence is required. That is where a strong willingness and desire is required. The intent of this workshop was to show you the opportunities. We will have many more in the series to talk about how each one of you can make a positive difference to the world that we are going to see in a few years from now. So all the best, and we would like to thank Saibal and Sankalp for giving their time to us with a small token of appreciation. So someone else has to speak. Saibal.
So thank you so much, sir. And sir, please join us on stage for this wonderful.
So this is a painting made by our students.
Wow.
And we felt that there's nothing better than something that our students created
Sure.
to express our gratitude to you.
This is Kathakali.
Yes.
Great.
Sankalp.
Thank you.
See, I'll just take 1 minute. What Anuj said, see, there is umpteen number of opportunities. What is important is that if you get a grip on this, maybe a set of you think of a project, not a single person, try to work in a team, and try to do some implementation. And the experiences, the pitfalls, the problems that you face, that could be shared, So one cannot do everything, but one can learn even from others' problems and issues which arise.
You guys are lucky that you are in this campus and having such facilities, and people are like Anuj sir and sir is willing to spend time with you guys to do innovation, create something, and pushing you guys towards the innovation, not just theory, reading the books, getting the exam, getting the mark. This is very good thing. So you just do follow these things, think of anything different from the theory. These guys are there. If you want us to support you, we are there. You can reach us, like sir said, you can reach us directly. And if there is anything we can do for you guys, we will be grateful. Okay?
But